This is problem number 5, and it says a father racing a son has half the kinetic energy of the son, who has a third the mass of the father. The father speeds up by 1.6 meters per second and then has the same kinetic energy as the son. What are the original speeds of A, the father, and B, the son? So the first step in this problem is to write our givens, which are the kinetic energy of the father equals half the kinetic energy of the son, and that a third the mass of the father equals the mass of the son. So after we get those givens established, we can start to form an equation that uses these to figure out the velocities. So we can start by saying the mass of the father times. So this is the kinetic energy of the father, 1/2 mv squared. So 1/2 times the mass of the father times the velocity of the father squared equals, we said that the kinetic energy of the father, this, is equal to 1/2 the kinetic energy of the son. So we can put 1/4. The mass of the son equals the mass of the father over 3. So we can put that in for the mass of the son. And then the velocity of the son squared. So we can simplify that a little bit. We can get rid of this 1/2 and make this 1/2. And from there, we can't do too much with that. This is just our base equation. So we're going to form another equation and plug our variable that we find back into this equation. So the second part of the problem says that the father speeds up by 1.6 meters per second. So should I just write it over here? So the mass of the father times the velocity of the father plus the 1.6 meters per second that he speeds up by squared equals 1/6. That's just bringing out the 1/3 that we multiplied the mass of the father by, 1/6 mf times velocity of the sun squared. So these masses cancel. So we're left with velocity of the father plus 1.6 squared equals 1/6 the velocity of the sun squared. And then from there we can solve for velocity of the sun. I think this should be a 3. Yeah, this should be a 3. I'm sorry. My mistake. So if we solve for velocity of the sun, we multiply this by 3 and then take the square root. So the velocity of the sun equals square root 3 VF plus 1.6 squared. So that's the velocity of the sun that we found. So we can plug that back into this equation to solve for the velocity of the father. So we have mass of the father times the velocity of the father squared equals 1/2 times the mass of the father over 3 times, and this is where we substitute for Vs, so times the square root of 3 times velocity of the father plus 1.6 squared. So now we can start to solve for VF, which gets a little tricky, but it's doable. So these 3's will cancel. Well, we can rewrite this as 1/2 mass of the father over 3. And then this square will cancel with the square root. So that times 3 VF plus 1.6 squared. And these 3's will cancel. So, and these masses will also cancel. So if we multiply by 2, we have 2 velocity of the father squared equals, and then if we factor that, or if we distribute that squared, we have VF squared plus 3.2 VF plus 2.56. Simplifying that, we have 0 equals negative VF squared plus 3.2 VF plus 2.56. And if we solve that for VF, we get that VF equals 3.86. So that's the velocity of the father, which is part A. It's 3.86 meters per second. So that's half. The second half of the problem is to find the velocity of the sun. And that's a bit easier. So we go back to our original equation, mass of the father times the velocity of the father squared equals 1/2 times mass of the father over 3 velocity of the sun squared. So these masses again will cancel, and if we plug in what we know, which is 3.86 squared equals 1/6 the velocity of the sun squared, we get that the velocity of the sun equals 9.46 meters per second. That is it.